Now for this question, you have an object initially at rest and it's dropped from a height of 50 meters from the high tower, ignoring air resistance, and that the GPE on the ground is 0. So they ask you, a bit different for this question is they ask you in terms of ratio of the kinetic energy to its potential, gravitational potential energy when it's at the height 10 meters away from the ground. So it's released from 50 as you can see here. So to make it easier, let's label this point as A and this point as B. Now, back to your basic concept. So initially at A, when you release it from rest, all the energy, the total energy at point A is just your GPE at point A. Okay, there's no KE because it's released from rest. On the other hand, the total energy at point B is the same as total energy at point A because conservation of energy and there's no air resistance. So total energy of at point B is a combi of your GPE at point B plus kinetic energy at point B. Because it's moving down, it has a speed and it has a height of 10 meters, therefore it has GPE. Now this is your usual concept, okay, based on conservation of energy. So what you need to do now is, now if we in terms of, because no numbers are given to you except the height, so let's GP equals to mgh. Now the height here at A is 50, so the total energy at point A is equivalent to mg50. So we are going to express everything in terms of mg and the height. And for here, let's simplify this. As we know, total energy at point A equals to total energy at point B because conservation of energy remains constant. So in other words, total energy here is equivalent to mg50 is equals to the GPE at point B will be mg and the height now will be 10 and plus KE at point B. Now you do not open this up to half mv squared because I want the whole kinetic energy at point B, not finding the speed. So if you were to simplify the KE at point B, then that is the same as mg50 minus mg10. So the kinetic energy at point B is equivalent to mg40. So once you have all the data, the answer asked for the KE at point B is to GPE at point B. So as we know, the KE is mg40 and the GPE at point B is just mg and the height 10. So if you simplify and cancel, the ratio will be 4:1. So that's how you do it normally.